Okay, how about Miguel? Where's Miguel? All right, Miguel. I'm going to bring the 5 down for you, even though you probably already know what to do with that. I want to know what the derivative of this piece right here would be. So what would come first?
Bring the other 5 down.
Okay, bring the 5 down, and then what do you want me to write?
And then parentheses.
Uh-huh.
X squared plus x minus 1 to the power of 4.
Good.
And then that's going to be multiplied by
So times,
x to the power of 1
what are you doing now?
I'm getting the derivative of x.
Of this, right?
That should just be x plus 1.
Careful on that one. Derivative of this one?
2x.
2x. Okay, so you have 2x. That's derivative of this. Plus derivative of that you said was 1, and then derivative of -1, which was 0. So, like,
Just like that, and then parentheses.
parentheses. Okay, good. Parentheses around that. That's it right there. Do y'all see it? Okay, now I can clean this up a little bit. This I can make 25. And then I could write x squared plus x minus 1 to the 4th times 2x plus 1, like that. You could even move this parentheses and squeeze it right here between the 25 and this parentheses. It really doesn't matter. Multiplication can be moved around. But that would be it. You do not have to try and figure out what this to the 4th power is. That would be a disaster if you had to.
So can you multiply 25 into that?
Oh yeah, you could do the 25 into this if you wanted to, but normally we wouldn't, because we would want it to be as factored out as possible. And so if you put a 25 in here and here, and then someone asked you to factor it, you would pull the 25 out. So now it's already there. So this is be it. You box it up. Are there any questions on that? Is it all right? Let's do another one. How about this cost function? I want the derivative of this. Let's see who's unlucky today. Miguel, I got you. Was it JR or Junior? Junior, right? I put JR here. Junior, you're lucky. You got the lucky one. Okay. Because I haven't shown you one like this. So I'm not expecting for you to see this right away. I'm telling you, though, that this is a chain rule problem. You are allowed to do, you can do the power rule. Problem is, you don't see a power out there, right? But do you remember what the square root means?
Yeah, square root, it's, so it'll be 3x plus 1. Oh,
10.
plus 10, it'll be negative. Or it'll be negative 1/2.
Close. This is 3x plus 10 to the positive 1/2. That's what that means, okay? So when we see a square root, it means raising it to the 1/2. We've talked about this already, right? So this is, no derivative has been taken, right? Just rewriting the problem so that you actually have something to a power. Now, would you like to go with the derivative now?
Yeah.
Okay, go ahead.
Oh, wait.
So if I was asking you to take derivative of this, what would happen first?
Bring down the 1/2.
Bring down the 1/2. So I'm going to have 1/2. And then what?
Parentheses.
Parentheses.
3x plus 10.
3x plus 10. And now, you need a power on this, though.
Okay.
Remember? So you got to subtract 1 from this, right?
So it'll be negative.
Negative 1/2. So if you take 1, sorry, if you take 1/2 and subtract 1 from it, you get negative 1/2. Now you go, keep going,
So that'll be times
times
3.
times 3. And I don't need parentheses around the 3 because it's only one term. And where did the 3 come from again? Junior?
You derive.
You derived what was in here. And derivative of this is 3 and derivative of that is 0. So you just get 3 there. So this becomes, how about this? 3/2, 3x plus 10 to the negative 1/2. I could bring that 3 out to the 1/2, couldn't I? And I could go even further. Let's see if this looks crazy to you. Isn't this the same as this? It is. Look, the 3's up top, right? 3's up top, 2's on the bottom, right? Now, this to a negative power means drop it down. And when I drop it down, it becomes a positive power. And what does this to the 1/2 mean? It means that, doesn't it? The book is going to have the answer like this, most likely. So you need to know where it comes from. How did that feel? That all right? Oh, you're not gonna like me after this one. Okay. Now, you see that problem right there? That's a 7. Sorry, that's a 7 up there. This problem right now, if I asked you to take the derivative, how could you do it? There's actually 2 ways you could do it. You could do a product rule, right? Or if you were kind of clever, you could just distribute, right? You could just distribute that through and then just do power rule. Yeah? Okay, this isn't the problem. Hold on. To the 8th power here. Okay? So now, with that 8th power here, you cannot distribute this through because order of operations says that you must raise things to powers before you multiply. So if you want to try and sneak around the product rule, you're actually going to have to expand that out first. That means you have to do x squared plus 1 times x squared plus 1 times x squared plus 1 times x squared plus 1 8 times. That is going to take you 20 minutes to do. And then you're going to distribute this through to that answer. That's going to be not fun, all right? And even if you were like, well, I could do that, I'd rather do that than this, I would just change that to an 80, right? And then you can't do it, right? So how in the hell are we going to do this? Well, you have that. Do y'all see that by itself? You could use the chain rule on that. Like the 8 could come out, that to the 7th, and then times 2x, right? That's if it was by itself, but it's not. It's attached to this, which means that we actually have a product right here. And that means we have to do the product rule, right? I can call this F and I can call this G. Now follow me on this. It's going to be a little ugly, but let's see how this goes. Y'all understand I have a product? Okay, derivative. I know y'all can do this, so I'm going to just keep calling on people. Jonathan's not here. Stephen Taylor. Oh, wait, Stephen's not in this class anymore. I'm going to take his name off. Okay, we've gone through everybody except Jonathan, who's not here, unless he's saying he's staying quiet. No? All right. Ooh, lucky number 2. Oh, wait, how about Caitlin? Is there a Caitlin here? I think Caitlin's gone too. I'm generating a random number here. Lucky number 8. That's Emmanuel. Where's Emmanuel? All right, Emmanuel. So product rule, I'll write the formula down for you here. If you have a product, it's f prime g plus g prime f. I've identified here for you, Emmanuel. Emmanuel, is that what you go by? Okay. I've identified what f and g are. So you're kind of going to get lucky here because I'm only asking you for these 2 pieces. So what's f prime, Emmanuel? Uh-huh. Uh-huh. 35. x to the 6th. Good, that's f prime, right? So we got that. Then times,
And then you put parentheses.
uh-huh.
Squared plus 1, close parentheses to the 8.
There you go. That's it right there. Everyone see that? This is f prime times g plus. Now, who's the lucky one that gets this piece? 14. Carlos, you get it again. It's a random number generator, sorry. So Carlos, I think he's working. Right? You there? Are you Carlos? No? Miguel, hold on. Where's Carlos? I marked you as Carlos earlier on accident. No Carlos, huh? He gets a 0. 18, 13, 12, 11, 10. Aaron. All right. I should know your name, Miguel. I should know your name. I'm bad with names. I apologize. Okay.
It'll be 8.
So you're doing g prime, right?
Yeah.
And this is the part that's tricky in the problem, because the derivative of g is the derivative of this thing, right? And to do the derivative of that, you're going to actually have to use what? The chain rule. Okay, so to do this one little piece of this formula requires the chain rule. So go ahead and give me the derivative of g.
It'll be
8 parentheses, x squared plus 1 to the 7th times parentheses 2x. Okay, excellent. Does everyone see that's g prime? And just g prime, right?
Yeah.
You still have to tack onto that times f. So I have to tack onto this what? 5x to the 7th. Oof. Okay, so let me go back here and illustrate again. This right here is f prime. This right here is g. They're being multiplied. This whole thing right here is g prime, and this whole thing right here is f. Do y'all see all the pieces to that? So you could say this problem right here, to take its derivative, required a product rule, didn't it? But within that product rule, you had to do a chain rule. Yes, that's fair to say? So it required the product rule, but within it, you had to do a chain rule. Question? Yes?
Why did you have to do a chain rule for G? Why couldn't you just do the power rule?
Because g is not just x to the 8th, right? It's some junk to the 8th, so you got to go through the whole process of taking its derivative, whatever that may be. That's about as bad as it's going to get, okay? It's not going to get any worse than that, all right? Okay, we're out of time. Let's see here. I do need y'all to sign in. Who always gets this last? Who always feels like y'all get this last? The sign-in sheet. No one? All right, we'll start it back there. Make sure you sign in. We still have 2 minutes. I'm going to say that we're going to say class is done. But make sure you sign in. What's up? What, here? Oh, you have to clean this up? Yeah, you know what? We would have to clean this up.
I was like, you leave me hanging like this?
Yeah, let me write the next line while y'all are packing up. Okay, so I would put the 8, the 2, the 5 together. So 8 times 2 is 16 times 5, right? 40. That's going to be 80. So 80 x to the 8th. And then you have x squared plus 1 to the 7th.
And that would be the answer?
Not quite, but that would be correct. I mean, that is the derivative, but it's not the way the book would probably have it. What you could do now is you could factor, but let's just leave it like this for now, okay? Let's just say that that right there is good enough.
Okay, I got kind of confused. I still don't get it. So
Y'all are free to go once you sign in.
when you do the x, or 8 to the x squared plus 1, I understand how he
hold on a second. Does everyone understand that the homework is to do 11.3 and 11.4? That's product and quotient rule and chain rule. The video for the chain rule homework solutions will be up either today or tomorrow. Okay? All right, go ahead.
So, why did you bring up 2x?
Right here?
Yes.
Okay, so let's do this. What if I gave you this problem right here? Forget all that, okay? Forget everything up here. What if I gave you this as a problem and I asked you to find its derivative? Right? Are you okay with the idea that this would require chain rule? Because you got something to the 8th. So you would bring the 8 out, right? You do x squared plus 1 to the 7th. And then because of the chain rule, you would then need to multiply by what? Don't look up there, right here.
You would need to multiply by f's derivative.
F's derivative. And this is f, isn't it?
Oh,
Which is 2x?
yes.
Okay, so now that's what you would do if I was asking you to take derivative of just this, right? On this problem, I'm not asking you to take derivative of just that. I'm asking you to take derivative of that times this, right? So you have to do a product rule because these are multiplied.
Okay, now that makes like
You see?
complete sense.
So yeah, so this piece right here
I always
is
forget-
just the derivative of that,
I always forget the derivative of f.
of f, and that's the part of chain rule that people forget. And they call it the chain rule because it's like you have a function inside of a function, so you create this chain. And people always leave that last little link off the chain.
Yeah,
That
would be my
piece.
mistake.
Yep.
Like what I noticed on the quotient rule,
Uh-huh.
I always do this is forgetting the denominator.
The g squared? Yeah.
I'll get the whole top, but